Recording the session. Okay. So good afternoon, everyone, and thank you so much for coming. I'm Milena Viceconte, and I'm one of the convener of the Cambridge Disaster Research Network, which, as you might know, is a network that aims to be an informal space for conversation and exchange of ideas between scholars inside and outside Cambridge, interested in disasters and hazards. Today's seminar is the last one of this term. Due to the strike action, we decided to postpone to next term the seminar Rumors, False Information and Disasters That Never Happened, scheduled for the last, for last 22 of February, but we will let you know as soon as possible the new date of this seminar. As you probably know, the underlying theme of this term was focusing on questions of what causes disasters and what we can do about it. Today, we will like to stress particularly on historical processes and take into account issues related, for example, with the social construction of the risk, the interaction between local and global in managing disasters, and of course, the cultural and educational dimension of disasters. For that, we have I'm so pleased to be two speakers today, Dr. Katrin Kleeman and Dr. Elisa Sevilla. Thank you very much for accepting the invitation. And I'm also honored to introduce Professor Greg Bankoff, Emeritus Professor of Environmental History at the University of Hull, who kindly accepted to participate as a chair and discussant of these questions. Professor Gregory Bankoff is an historical geographer with a long academic career and a number of papers and books focusing on the relation between history, disasters, and community, especially in Philippines. As you might know, speaker's presentation will be recorded, and after Professor Bankoff's consideration, we will have a time for questions. So please feel free to write your questions in the chat or raise your hand when we started the debate. So Professor Bankoff, over to you.
Thank you very much, Milena, and good afternoon, everybody. It's a great pleasure to be asked to introduce the speakers this afternoon and be the chair of this session. And I'll get straight to it because I know we should leave plenty of time for discussion at the end. Our first speaker is, and I'm presuming you are German, Katrin, so I'm going to say Kleeman and not Kleeman, right? Right, okay. Is Katrin Kleeman, who is a postdoctoral scholar at the German Maritime Museum in Bremerhaven. And she completed her PhD in 2020 at the Ludwig Maximilian University in Munich. And you're going to be talking about Iceland. Over to you.
Thank you very much. Let me just get my presentation started. You should be able to see my presentation now. Great. All right. Yeah. First of all, I'd like to thank Greg Bankoff for the kind words of introduction. And I'd also like to thank Milena, Rory, Hannah, Camilla, and Sarah for organizing this event and for inviting me. Today, I would like to speak to you about the Laki Eruption of 1783 and use this event as a case study to show what disaster mitigation looked like in Iceland at the time, and briefly what disaster management looks like today in Iceland and in Europe in the face of a future event like Laki. And before I start my presentation, I would like to show you my book, A Misconnection and Environmental History of the Laki Eruption and its Legacy, that is coming out open access and in print in the Reuters Historical Catastrophe Studies series later this year. So something to look forward to. My talk today has three parts. And in the first part, I will look at the Laki eruption and the social construction of risk. The Laki eruption was a flood lava event that took place between the 8th of June 1783 and the 7th of February 1784 in Iceland, which is located here. Over the course of this 8 months long eruption, the fissure reached a length of 27 kilometers, out of which it released 14.7 cubic kilometers of lava, which equates to 5.8 million Olympic-sized swimming pools. These covered an area of 600 square kilometers, which equals the urban area of the city of Birmingham, just to give you an idea. The area covered by lava can be seen on this map in dark gray. And this was the largest volume of lava released by any eruption on planet Earth in the last millennium. And the bottom picture gives you an idea of what this eruption might have looked like. This is what the Laki fissure looks like today. And here on the bottom picture, you can see the southwestern part of it. And here you can see the northeastern part. So this photo was taken from Mount Laki, which is in the middle of this fissure. This volcanic eruption has many names. In Iceland, the fissure itself is known as Laki, the craters of Laki. However, the event is primarily remembered for its consequences, either as Skafta Elda, which means the Skafter fires, in reference to a river in the area that evaporated during the eruption and flowed instead with lava, which then overran meadows, fields, churches, and farms in the southeast of Iceland. The eruption is also referred to as Muduhadindin, which means famine of the mist. In Iceland, the volcanic ejecta poisoned the fields and therefore the animals feeding off them. 76% of the horses, 79% of the sheep, and about half of the cattle perished. This caused malnutrition, famine, and diseases in the human population, which led to the death of about 10,000 Icelanders, a fifth of the population at the time. The hunger catastrophe of 1783 was not the first in the 18th century in Iceland. Death and disease spread throughout Iceland in the country's pre-modern period. In the 18th century, Iceland was prone to famines and epidemics, which killed around 20% of the population between 1707 and 1709, and 1754 and 59, and then again between 1783 and 85. Iceland is located close to the Arctic Circle, and very little grows here in a very short growing period. So if this short window of the growing period gets disrupted by bad weather, for example, it's problematic. It was difficult to put resources to the side for bad times. And resources were also distributed unevenly within Iceland, and the poor were more likely to perish than the wealthy. The living conditions of most Icelanders, although not entirely to blame, did not help. Their houses were built from turf and stone for lack of timber. They were ramshackle buildings that leaked and were poorly ventilated. These factors, together with the inevitable damp and cold, battered residents and left them susceptible to disease. The consequences of this eruption did not only affect Iceland, they were international. In addition to large volumes of lava, the eruption also produced large volumes of volcanic gases, particularly sulfur dioxide, that were transported beyond Iceland by the jet stream. Within a few days, these gases reached continental Europe, where they became visible as a dry fog or haze, characterized in some places by a sulfuric smell. The Laki haze covered large parts of the northern hemisphere, which is illustrated by the image on the left on this slide. And on the right, I indicate the dates of first sightings of the Laki haze that I came across in my sources for the month of June 1783. In Europe, this haze lasted for about 3 months. In addition to the dry fog, the summer in Europe played host to a blood-red sun, numerous and severe thunderstorms, a great heat in Western and Central Europe, seemingly more earthquakes than usual, reports of several volcanic eruptions in Germany, newly emerging island off the coast of Iceland, and a long-lasting meteor over Western Europe. What makes this eruption so interesting is that those outside of Iceland were oblivious to the fact that an Icelandic volcanic eruption was taking place. Naturalists and amateur weather observers were left alone to speculate about the origin of the dry fog, and undoubtedly inspired by the Enlightenment developed theories ranging from the mundane, such as heavy rainfall, to the extraordinary, such as large amounts of sulfuric gases released by earthquakes in Calabria, or blaming the recent installation of lightning rods for attracting lightning and causing hazy air. In 1783, Iceland was a Danish dependency and subject to a trade monopoly that only allowed certain Danish merchants to trade with Iceland. Copenhagen is around 2,000 kilometers away from Iceland, and so the only method of communication between the two at that time was by Danish merchant ship. When the merchants returned to Copenhagen in early September 1783, the merchants brought with them the news of a volcanic eruption, which was subsequently printed in newspapers in Copenhagen and elsewhere in Europe. Because the first news of the eruption only arrived in Copenhagen in September, a ship with men to investigate what was happening in Iceland was sent off in autumn. Adverse weather conditions made it impossible to dock anywhere in Iceland, and the ship was forced to winter in Norway instead. In the spring of 1784, they set sail again and landed in Iceland in April. And although Icelandic officials, which are the governor, district governors, or sheriffs, were allowed to prohibit the export of foodstuffs in case that there was a threat of famine, they did not feel comfortable to use this prerogative in 1783 without discussing it with the central administration in Copenhagen beforehand. And therefore, they still exported Icelandic produce. And of course, they did not know yet how bad the winter would be. Another Danish vessel that carried some emergency supplies was sent to Iceland and stranded in southern Iceland. But in that year and in 1785, more help was sent, mainly barrels of rye and later also timber. And the Danes donated money to the suffering people of Iceland, but according to German historian Paul Hermann, they only received a quarter of the donations, and the rest was instead used for other purposes, such as measuring and mapping the coastline. Yes, so now I'm gonna come to the second part of my talk, which deals with mitigating the risk of frequent volcanism in Iceland. What is unique about Iceland's geology is that the interaction between the Iceland mantle plume, which started to become active about 130 million years ago, and the mid-Atlantic ridge formed Iceland. Iceland first appeared 24 million years ago, from which point onward it continued to grow, and to this day it still continues to grow every year. On this map, you can see Iceland's 30 volcanic systems that produce 20 to 30 volcanic eruptions per century, or one every 3 to 5 years. And the circle that you can see in the middle of the map, that's the approximate location of the Iceland mantle plume today. And to put this into a broader perspective, Iceland's volcanoes have produced roughly 2,400 volcanic eruptions since the end of the last ice age, including at least 213 eruptions during the historical period. Scientists have established this from tephra layers, which you can also see in this image on the slide, tephra layers in Iceland, and also ice core records from Greenland, where many Icelandic eruptions deposit tephra. And Iceland was first settled in around 871 AD. And for the last 1,150 years or so, we also have some historical records to add to these ice core or tephra records. Icelanders took to raising livestock instead of growing crops because in emergencies, animals could sometimes be relied upon to fend for themselves by grazing in the highlands and moving out of harm's way. The flexibility of subsistence farming and the use of wild resources in the highlands, such as picking berries or birds' eggs, allowed the population to deal with setbacks brought on by either cold winter or volcanic hazards. This was crucial as Iceland was almost always left alone to deal with the consequences. Only a handful of flood lava events took place since the 9th century. And this, what you can see on the slide, is what a small-scale flood lava event looks like. The most notable flood lava event took place in 939-940 AD, which was the Laki Eruption. And Laki means fire fissure, because it erupted along a length of a 75-kilometer long fissure. This eruption produced more lava and gas than Laki, but it occurred shortly after the settlement, so it might not have been noticed as much, or it might have been forgotten again, because it's been a almost 800-year time span between the two eruptions. By 1783, Icelanders had lived with their natural environment for almost 900 years. It's throughout the history they had fended for themselves in the face of volcanic eruptions or hazardous weather conditions, and so learned how to mitigate their effects. Isolated from Europe by hundreds of kilometers of ocean, they developed a communal resilience rather than a dependence on Copenhagen. Help in the shape of resources or refuge often came from areas within Iceland that were less affected. Creatively, they looked for internal solutions, such as clearing the tephra from the fields so that grass could grow and animals could graze again. Similarly, they relocated farms that were destroyed and created new paths for those cut off by lava. While the Icelanders had adapted their lifestyle to the frequent volcanism in their country, around 95% of the population's livelihoods depended on farming, animal husbandry, and fishing. The fact remains that the Laki eruption was of a size that only occurs on average twice per millennium and produced a volume of lava that was unmatched by any eruption on Earth in the last 1,000 years. Icelanders could not have known that this eruption would hit them so hard. They were not prepared for the size of the devastation and the aftermath of the Laki eruption. Farming, animal husbandry, and fishing were severely disrupted by the volcanic eruption. Additionally, the trade monopoly did not help the situation either. Overall, the short-term response of the distant central administration in Copenhagen was too slow, and the aid provided too little to effectively ensure the survival of many Icelanders and their livestock. Excuse me. Okay, so now this is the third part of my talk, and this one deals with disaster management today and the interactions between the local and the global. So scholars have determined that a Laki-sized volcanic eruption in Iceland statistically occurs every 200 to 500 years. And in order to mitigate the potential hazards of a future eruption, knowledge of recurrence periods is crucial. It has been 239 years since the Laki eruption occurred. And although the exact timing of the next flood basalt event is unclear, it's safe to say that one will happen again. Iceland is one of the most active volcanic regions on our planet. Today, the different volcanic systems are monitored continuously, which has yielded a lot of information about Icelandic volcanoes and their behavior. Since 1996, every eruption in the country has been predicted by seismic activity, sometimes just a few hours before, which gives civil defense authorities some time to evacuate people from the threatened parts of the country. Seismometer-based active warning systems are in place in the area and have successfully warned people in the past when an eruption was imminent. These technological and economic improvements in Iceland have undoubtedly saved many lives, and only 2 fatalities have occurred during the 20th century. Increasing tourism places tourists at risk as well when they are hiking in areas that potentially have erupting volcanoes in them. In 2010, Iceland's volcanism made global headlines when Eyjafjallajökull erupted that year. And I'm sure you all remember this and have seen pictures of it. The eruption's ash plume filled Europe's skies for several days. And one consequence that we did not see in 1783 was the grounding of all transatlantic air traffic and stranding 7 million passengers. Of course, today, we do know about Icelandic eruptions almost instantly. In the last few, there always were webcams where you could instantly watch these events happening rather than hearing about them 3 months later, like in 1783. Fortunately, today, some countries are already planning for this kind of scenario. So, for instance, the United Kingdom has listed a Laki-style Icelandic eruption on the National Risk Register for civil emergencies. The German Federal Office of Civil Protection and Disaster Assistance has a similar risk analysis list. The specifics are here not public, but they do include the risk of volcanic eruptions. And in case of future volcanic eruptions that affect Germany, the different state governments would respond to the risk individually, and the federal government can then offer their assistance, like we have seen with COVID as well. And other countries in Europe have similar lists as well to prepare for volcanic emergencies. And in general, proactive measures could include the development of Tefra-resistant airplanes or airplane engines, and also, for example, suitable face masks. And we can only hope that Iceland and Europe are prepared for the next Laki-sized eruption. Thank you very much for your attention, and I look forward to your questions.
Thank you very much, Katrin. We'll move straight on to our second speaker, and questions, of course, later after we've heard everybody. Our second speaker is Elisa Sevilla Perez, and she's a lecturer at the Universidad San Francisco de Quito. And she's working on disaster risk and the global circulation of knowledge in the 19th century. That's what I was told, but you're going to be talking about the 20th century and right now. So I'll leave it to you.
Thank you very much. So yes, I come from history of science, but now I'm working also on the history of from a forensic analysis, but also public history. So I'll talk a bit about all of those aspects. So thank you very much for inviting me and for letting us share this work that is not only from me, but a big group of interdisciplinary researchers. So this is part of the Tomorrow Cities Urban Risk Hub from GCRF, and we are working in several cities. In the case of Quito, we've had a very strong focus on the history of events, but also how the trajectory of policies and urban development are intertwining in creating the conditions for disaster risk. So what I'll be talking to you today is on twofold work that we're doing. On the one hand, trying to understand those historical processes, but also to communicate them for reducing disaster risk in the future Quito. So one of the strands of work that the hub has been doing is co-producing forensic examinations to understand these root causes and drivers of vulnerability and trends for decision-making culture for key historical multi-hazard events. So the idea is to try to understand from the past those trajectories of risk. So what I'll focus here is what role that the historical methods play in this idea of reducing disaster risk in the future. So how to combine those two, because those two aspects, right? Talking about the past, but trying to have an impact in the present, so we can have better cities in the past and not so many disasters. So we do come from this idea that that disasters are socially constructed, and that we need to understand the root causes of risk, and that has to do with using the historical methods to identify these root causes, but also to understand the long-term trajectories of risk. And I'm really happy to have you, Greg, here for commenting, because we think that it is important to understand the relationship between humans and culture and how we deal with risk, but also how it is difficult sometimes to change those aspects that are more rooted in culture. So this is how we are today. We have compiled many timelines of different extensive and intensive events of urban growth, of policies, of urban planning, etc. And now we're writing a paper trying to get all that information together and trying to see patterns. And we decided to take a long-term perspective, and so we have collected information since the foundation of the colonial city in Quito in 1534, and we come to the present. So Greg, if you were saying the 19th century or the 20th century, we went back to the 16th century as well, trying to see those patterns in the long term. And so one of the difficulties we're having right now, and we're addressing, is the different types of data, both qualitative and quantitative, and how we can pull these things together and try to see some patterns. So we do have a few first conclusions. One is the importance of inequality and economic limitations for development that takes into consideration risk, because we see that the people that are most affected by the disasters in Quito are mainly affected by everyday hazards related to rains and how that interacts with the soil. And so sometimes those events are not so visible. We just had one that was very visible and at the end of January, and but in other years we have very few news about this, and policy doesn't account for that. The other is the lack of compliance to norm in city planning. So there is city planning, but there's a lack of compliance and the lack of the local government to make them effective. And also there's sometimes the difficulty on getting scientific information into decision makers. So this is another area that is very important. There is scientific knowledge, but sometimes it doesn't get to those that build the city. And then also these cultural factors, both that affect vulnerability, but also build capacities. And so we've identified the Minga, that's the work, community work for public interest, but also the relationships between groups, and with power that sometimes interacts as a way of not through the channels that institutions have, but more about personal relationships and how you get the government to act for your community. So as I was saying, we compiled these timelines of intensive and extensive events, and also we tracked how the urban setting has been growing, and the policies regarding both urbanization and also risk management. And what we are trying to do right now is understand how people managed and also coped with disaster risk. So both things. I'll stop sharing just to show you again. No, I shouldn't stop sharing. I have to just stay here. Let's get out of presentation mode. So I'll show you a bit of this work that we've been trying as well to communicate to the public. So we've built this platform for education, and here we have put some of the information that we already have in a way that is interactive, but also that you can try to see these different interactions of different things. So since we started doing this work in the pandemic, we also did a timeline of epidemics in Quito. And the idea is that you have this interactive where we have this idea of a qualitative also information about the testimonies of, for example, the earthquake of Riobamba that also had an impact in Quito from 1645, or the eruption of Pichincha of 1575, or so we have lots of events, and the idea is that we have this idea of using historical documents, but also some more contemporary gifts and etc. The other thing that we've been the other database was about of the extensive events, those that happen every year because of the rains, and so we have the alluvions or mudflows, hundimientos, I don't know how you say that in English, inundations, and also landslides. And so this is also built on that database, and you can either go through every year and see what is happening in the city of Quito. You can zoom in and zoom out to a particular neighborhood, but also we wanted to make that link between urban development and these type of events, so you can also see how the city grows in different periods that we've identified that are crucial times of expansion, and you can see the events related to those periods. So the idea of these of this website is both to at the same time that we are producing these these data sets, to interact with the public and have a communication of that. So I'll go back to my presentation, and please, Milena, you can let me know about the time. So as you see, we've been working on trying to have this information so we can have correlations and identify these root causes. But at the same time, we decided that we need to interact with a public debate about risk, and to break this idea that disasters are natural, and also regarding the culture of Quito, that it has to do with how we behave in relationship with religious thought. And so the idea is, from the beginning, we wanted to interact with the public, and during the kickoff that never happened because of the pandemic, that was supposed to be in March 2020, we planned to do some interactive exhibits in parks and plazas of Quito that included a theater that was based in historical events, and also activities that were related to those exhibits. And the thing is that didn't have the chance to do it because we were locked down in the middle of March. But we decided to adapt our strategy and find partners in the museums of Quito and the digital education space that was so needed for materials during the lockdown. And what we've been working at is discussing these testimonies and interacting with also different parts of how to display this with artistic media. And the idea was to engage people through their emotions of these events with the testimonies from the past. But we didn't want to scare people, just get them to think about their death and life, but to say that we can act upon it. So that the idea was to talk about urban development as well, and examples of resilience in what people have learned from these events in reconstructing the city. So the idea was we don't need a big event, so we need to have the opportunity to reconstruct, including risk, but we can learn from those events in the past and develop the new city with risk in mind. So I wanted to share you a bit of those narratives that we've done in the platform. Some of them we also put them in the exhibits in 3 museums. We've put some exhibits in, but I wanted to show you that we talk about both volcanic eruptions, earthquakes, but also hazards related to rain and soil. But we discuss in all of them the idea of politics, urban growth, and scientific knowledge as well. And so I wanted to show you, well, and also engineering, how you can build your house and be safe. And so I'll show you, well, I thought it was already up, sorry. And so we have these narratives where we discuss, for example, urban growth and have these charts also from census and from the historical data from 1533, the foundation of Quito, up to 2020, no? And so we show people that it has grown a lot. And the idea is to using also digital imaging of how the city has been growing, discuss these different ideas that not only risk is caused by natural hazards, but also by, for example, the indifference, corruption, and other types of social behavior. And so we discussed this idea of how to plan and develop history, and we interact also with the culture of the religious culture of Quito. So this is something that I wanted to focus a bit on, is that we have this city, the saint from the city, that it's from the colonial period. But in the 20th century, there was this phrase attributed to her, that Ecuador is not going to disappear because of earthquakes, but because of bad government. So we've taken, and people use this a lot now, they use it in memes, especially when there's some political, how you say this, a scandal. So it is interesting because there's this discussion about that we can do something about bad government, right? We can do something about that. And the other thing that I wanted to show you is the idea of using historical testimonies, but also to imagine what would happen if there was an eruption, for example, of Cotopaxi in 2042. There's that date was chosen by chance, but we did these podcasts of our character that it's called Andesita, that she can travel in time, so she can travel to the past. She does many traveling to the past, but she can also travel to the future. And so we discuss this idea of utopian and dystopian thinking based on historical examples of what happened in the eruption of 1877. But now that the city has grown into areas where the lahars passed during the 1877 eruption, we can see these two types of scenarios, right? So that's part of the work that we have been doing. Also, this idea of imagining futures by using this historical data. I don't know how I'm doing with the time, but the idea in the exhibits as well as in the platform, we have interactive displays where people can also reflect on decision-making towards reducing hazards. And so this one was in the Museo del Carmen Alto, which is the house of this saint that I was telling you about. And we work with that phrase about that Ecuador will not be destroyed by earthquakes, but by bad government. And we ask people to answer what would they ask the saint or their politicians or their community, so that they can avoid disasters in the future. So that we aim at making that connection with the decisions that we made today for the future. And the last thing that I wanted to say is this idea of using not only history, but also science. So much of the content that we did was history of science, but also how using art and also the social sciences, we can get to see this complexity of how disaster risk is so complex, and how to aim at solving it by identifying those historical roots and cultural roots as well. So I'll stop there and let me see how I can stop sharing. But yeah, yeah, there it is. Okay, thank you very much.
Thank you very much, Elisa, and thank you very much, Katrin. That's two very rich papers, and I have to say that I'm cold. This is the first I didn't get any paper in advance.